So today, busy day, we have two topics we need to finish, and those two topics would be the last two topics or the last topics we need to finish in the basic skills category of the course. Because tomorrow, what are we doing tomorrow? Does anyone remember? Tomorrow we're going where? To the computer lab, and we're starting to work on our ISP. By the way, just in case, like just to put your mind at ease here, your ISP is going to be divided into a couple of parts, and either part is due very soon, so you'll have enough time to work on it. So don't stress out about the ISP. I usually give ISPs just to boost everyone's markup, especially in a 4U course. Okay. So today we cover two topics. The first one is unit conversion. That's the handout you have right now, right there. And then the second one is scale conversion. Okay. All right. So let's start. So unit conversion. Okay. All right. So usually the most common units that we're going to start the course with are basically those ones. Okay. So common units for length are basically the mile, the kilometer, the meter. Obviously, some of them are exact and some of them are what, as far as we're concerned, approximate. The exact ones are the metric system. 1 meter is an exact 100 centimeters. 1 kilometer is 1,000 meters. 1 kilogram is 1,000 grams. And obviously, the time ones are all exact except for what? So the what? The year. Because is the year exactly 365 days? No, it's 365 days and also what? A few hours. That's why every 4 years you get a what? You get 366, which is called a what? It's called a leap year. Okay. Every other year is designated to be 365 years. Sorry, 365 days. Okay. The other ones that are approximate are the what? Are the imperial units. You know, the inches, the mile, the feet, and so on. For our concerns, we're just going to usually go either with one decimal or two sig figs in this case, I guess, or two decimals or three sig figs in this case. The only reason I am making a few of them bold is from my former days at Weeble when I required people to memorize at least some of them, and I just couldn't, uh, I couldn't finish the course without saying that I can't let anyone here finish 4U physics without knowing. And I'm always surprised, by the way, how many people do not know that a meter is what? 100 centimeters. They actually think it's 1,000, which is weird. You know why? What does the word centi mean? Centi. When you say percent, what does that mean? Out of 100. What do you call 100 years? 100 years. Century, cent. It's exactly that. Every single time you hear cent, you just think which number? Cent. You think 100, exactly. A kilo or milli, kilo is a what? Kilo is 1,000. That's actually our second job for the day is to get used to the scales. Okay? All right. So, um, unit conversion. Okay, that was before. Now you have like, you do stuff online, so you don't need to memorize, but you still need to what? Know how to use it. Okay? So for quick, basic 1 unit conversions, the above list, just remember why I always like to say the golden rule. To convert from a large unit, so for example, a meter, to a smaller unit, what do? You multiply. Think about it this way. Your number has to be bigger, right? 1 meter has how many centimeters in it? 100. So 1 meter, one is small number, but 100 is a big number. Always think of it this way, okay? You can't say, for example, that, 5 feet 5 feet, you can't say, oh, that's 2 meters. So that's 10 meters. That doesn't make sense. If 5 feet is 10 meters, that means each foot is 2 meters, which doesn't make sense. The number in feet always has to be what? Bigger than the number in meters. Here's an easier one. Your weight in kilograms versus your weight in what? In pounds. If you weigh, for example, 65 kilos, how much should you weigh in pounds? More than 65 or lesser than 65? More, because does anyone know how many pounds in a kilogram? 2.2. Yes, exactly. So 1 kilo is roughly 2.2 pounds. Okay, so always remember those quick conversions. Okay, now how many ways are there to do what? To do unit conversion? A few. But I'm going to teach you a method that I also believe is very popular with also chemistry teachers. Okay, they call the unit fraction method. Unit fraction method. So let's actually do this question right there. Okay, so you're at work at some job, and there's a tank that leaks 5.23 pounds of sand per what? So every single minute, if you're actually having a scale there, every single minute, that scale is getting heavier by how much? By 5.23 pounds. The question is, if no one does anything about this problem for how long? For a week, how many kilograms would have what? Would have leaked from the what? From the tank. Okay. So apparently, what mass unit? What mass unit did we start with? What mass unit is the problem starting with? Pounds. And what time unit is it starting with? So we want to convert the mass from pounds to what? To kilograms. And the time from minute all the way to what? To a week. Okay? So this is the way that I want you to do what unit conversion for this course. Now here's the thing. This is a mechanical skill. So I'm never gonna waste your time giving you a question on a quiz or a test or something like that. Convert the following. You might need to do that at some point. I am not gonna actually ask you just a question for unit conversion. Okay, this is a physics course at the end of the day. All right. So go ahead. Start by adding that. Go ahead. So 5.23 pounds. Is there another way to write pounds per minute? What's another way to write a fraction? Especially if you're talking about unit. Yes, you do the what? You do the slash. You do the what? The typing slash. Please don't do that if you're doing what? Unit conversion. Because unit conversion is all about fractions. And whenever you do fractions, you always want to see what? An explicitly one on top, an explicit one at the bottom. Okay? All right. Now, do I want to keep the pounds or do I want to ditch them? I want to ditch them in favor of what? In favor of kilograms. Same thing with minutes. I want to ditch the minutes, but in favor of what? Okay, so let's actually just look at the chart right there, everyone. Do I have a one-step unit conversion between pounds and kilos? Where is it? It's the very first one, right? Okay, that's good news. How about from minutes to weeks? Do I have a straightforward conversion? No. Do I have to do multiple steps and I get it good? Okay. First of all, you need to go from minutes to what? Minutes to hours, and then what? Hours to days, and then days to week. So for mass conversion, how many steps do you need? For the time conversion, does it make sense? Again, for mass, I have one shot, so it's just one single shot. But for time, I need to go from what? Minutes to hours, hours to what? Days, and then, okay, question for you, everyone, before you do anything. Pencils down. Who knows how to solve this? There are two ways to solve this. It's the same thing at the end, but there are two ways to approach it. Raise your hand if you have a way. Ammar. No, 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 no. I'm talking about this. I'm talking about this. Yes, it will lead to something like that. So who knows a way to do this one? Hamid. Sorry, say again. Why would you multiply by 2? Thank you. To what? To get rid of the what? Whenever you have a fraction, how do you get rid of both parts of the fraction? Whatever is at the bottom gets multiplied by its own self, but where? On top. And whatever is at the top gets multiplied by its own self, but where? At the bottom. So to really just isolate for just what? X, you need to cancel this or eliminate it by multiplying it by what? By its own flip. So 2 times 3. Also here is what? 2 times 3. What happens to these two? How about these two? So how do you always cancel a fraction or a part of a fraction? You always multiply it by the same location or the opposite location. There you go. And that's the whole idea here. So does it matter which one you handle first? No, you're going to have to handle both anyway. Let's start with the easy one. Which one of those is the easier work? Pounds. Okay. So pounds here will stay up, but in the new unit conversion will appear what? Will appear below. So our first step is this. Go ahead. So I did not do anything to the first part. I kept it. But now I'm starting to what? I am starting to manipulate things. Okay, so kilograms on top. And because I want this one to cancel, I've planted it at the bottom. And it couldn't be easier to put the numbers. Literally, you put the same numbers. Next to the kilogram, you put the number here, 1. Next to the pounds, you put the number here, 2.2. Okay, can someone tell me the next fraction to go from minutes to hours? How should the fraction look like? Raise your hand. How should the next fraction look like? Because we're done with the mass conversion. I need now to start my time conversion. Who would like to tell me what fraction would kill the minutes. Come on. So think of the same way. Minutes appear where? At the bottom. If you want to cancel them, you're going to need to use a fraction where minutes is where? At the top. واضح? Tell me the fraction exactly. So times what? 1 hour. But here's my question to you: are you going to put the hours on top or at the bottom? What? Okay. So what are you going to put at the bottom? You can. See, that's the whole idea. واضح? Look, 2 units have to appear for cancellation. Umayma? But I don't need to do second. See, you're thinking correctly, but you're doing a non-necessary step. Do you see what I mean? Do I need to go from minutes to second? No, I need to go from minutes to what? Pattern? So okay, tell me what's going to go on top. The 60 minutes. And what's going to go at the bottom? The hour. That will make sure that the minutes here cancel the minute here, right? Okay. Perfect. Can someone tell me my next one? I mean, I'm all good if the question wanted hours, but the question doesn't want hours. What's my next step? Come on. What's my next step? Sure, Ali. Hours today. Still need a fraction. Yes, because I'm trying to cancel it. Yes, and perfect. All right. I only have enough space for one more fraction. Who would like to do it? Jinan? Exactly. Days have to cancel, so they have to come here zigzag, basically. And what appears here? One what? One. You got it. Whenever you get to here, show me and yourself the what? Exactly, the cancellation line. Because that's the only way you can check. Cancel, 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 cancel. All right. Yeah, all of them. There we go. All right. 5.23 times 60. I'm gonna ditch the ones. Times 24 times 7 divided by 2.2. How many people got this number? Okay. So this number is up. Okay. How many sig figs do I need in this? Okay. Let's write it in scientific notation first. What is this number in scientific notation? Up to, like, let's say 4 sig figs. 2.396 times how many hops? How many hops? 1, 2, 3. How many? 4. So this is 2. Sorry. Oh, sorry. 2 point. What was it? 396. 396 times 10 to the what was it? 4. In what? In kilograms per what? Per week. Exactly. And by the way, when you write your final answer, please use the slash then. That actually would be the point of all this. Yes, Ayat? No, no, no. Now I'm gonna. I always like to do one or two more than the one I need, and then I will actually do the final answer now. So how many sig figs do I need? How many? 3. So I'm gonna do my cutoff right here. What does a 6 do? Does it keep things where they are, or does it bump them up? So can you just you can't go from a 9 to a 10. So what do you do? It's what? 2.40 exactly. So your final answer should be 2.40 times 10 to the what? Times 10 to the 4 kilograms per week. Can you write it as 24,000? What if you wrote it like this? Say again? That's only how many? 2 sig figs. So sometimes, by the way, it's not that often, but sometimes you actually need to leave your answer in what? In what? In scientific notation to guarantee that all of them show up. Okay? And that's basically how we do what? Unit conversion. It's just a matter of deciding what needs to be canceled and what needs to stay. That's all. Okay. All right. Let's do the next one. So now let's go to the worksheet or the actual. That. 1 second. All right. Unit conversion. Please go ahead. Yeah. Oh, I multiplied. Okay, let me just. I multiplied 5.23 times, because technically there's a 1 here. So 5.23 times 1, sorry, so times 1 times 60 times 24 times 7. And then all of that divided 1 times 2.2 times 1 times 1 times 1. Yes, yes, yep. You have to, again, you're multiplying a bunch of fractions, right? So you multiply all the tops together, you multiply all the bottoms together, and then you just divide the final result for each. Make sense? All right. Okay, come on. Next one. A snail moves, I have no idea if that's true. A snail moves 413.3 centimeters in how much time? 25.2 minutes. Okay. By the way, how many sig figs for the first value? For the first value. 4. How many sig figs for the second value? So definitely we're going by how much? We're going by the weakest, lowest link, which is 3. Good. I want the centimeters to go into what? And I want this minutes to go into. Okay. Is there a one-step conversion between centimeters and inches? Good. So we need one fraction for that. How about the conversion between minutes and hour? It's also what? One step. So really, how many full fractions do we need? Just do one for each. All right, let's do this. So, but am I giving you one number here or two now? So you can't just say 5.23 something per something. You have to say 413. So my first step is writing 413.3 over 25.2. And then I write centimeters per what? Per minute. That's exactly what the problem says. Times. Who would like to give me the first fraction? I don't care if you gotta do centimeters first or minutes first. Hmm. Josh. Okay. Sure. So which goes where? 60 minutes over 1 hour. Perfect. Times. Oh, we don't need a day. 1 hour and minutes. What did you say? 1 inch over 2.54 centimeters. Okay. Let me do the calculation quick. Okay. What do we have? 4.13 times 60 times 1. So 4.13 times 60 divided by, I'm going to open a bracket, 25.2 times 2.54. How many people got that? 387. All right. How many sig figs do I need? This has 4 sig figs. This has 3 sig figs. So I need to round this to 3 sig figs. So you're going to have to cut it here. Perfect. Any need for scientific notation? Nope, not too big. And there's no tricky zero at the end. So just what? 387. What? Exactly, because the minutes are gone and the centimeters are gone. So the only thing are exactly where you want them. Inches top, hours bottom. Inches per hour. All right. Looks good so far. Okay. Next one. A metal rod has a mass of 755.2. What does OZ mean? Ounces per foot. So a single foot of it weighs or has a mass of 755.2 ounces. How much is that in kilos per meter? So you want to go from imperial units to metric units. Okay. Do you have one number or two numbers given to you? One. So you don't have to put 75. You can put 755.2 over 1 if you like. So 755.2. And so far we have what? Ounces per what? Per foot. Okay. Times. Who would like to give me the first fraction? Umayma. Go ahead. Everyone, listen up. Just quick. Everyone, here's an easier way. Instead of worrying about the numbers first, just put the units first. Do you see what I mean? And then put the numbers because you can just look them up from the chart, right? You want to go, you want to go from what? Ounces to kilograms. Do we have one single shot? No. So we need to go from ounces to what first? Great. Just put OZ over G first. So, sorry, OZ here, right? And G here. Don't worry about the numbers. You can put the numbers at the end. What's my next fraction? Because I'm not out of the woods yet when it comes to mass. I already took care of ounces to grams. What's my next mass step? Yes, Ahmed. So where do things go? So kilograms here and grams here. Look, cancel, 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 cancel. Okay, time. I need to go from what? From feet to what? Do we have a one-step conversion? We sure do. So that means I will be done with feet is here, so it needs to cancel. So I have to plant it here, and then meters. You see how easy it is? Always be organized, and then you can slap in the numbers. So let's do the numbers. What numbers do we have? Yep, as an ounce is about 28.35 grams. By the way, a liquid ounce, like for liquids, is also almost the same. It's about 29 milliliters, though. Grams and kilos, obviously 1 to what? To 1,000. And then what was 3.28 feet exist in 1 meter. Great. And technically, there's an invisible one here. Okay, so let's multiply. So I need to multiply 755.2 times 28.35 times 3.28. So 755.2 times 28.35 times, no, no, yeah, times 3.28. Okay, that gets divided by just one number, 1,000. That's the only relevant thing in the bottom. 1,001. So you just divide this guy by 1,000, or you move the decimal point 3 times, and we get this. What's the sig fig situation for this problem? 4. 755.2 has 4 sig figs. So somehow we need to cut this at 4. So it's going to be what? 70.22, because the 4 does not do anything to the number before it. So the answer is 70.22 what? Because, okay, so let's see. This canceled. Feet canceled. Yep. Grams canceled. Yep. Kilograms slash meter. So a meter length of this would have a mass of about 70.22 kilograms. Is the method making sense now? That's all. Just be organized and just make sure that everything cancels out, and you will never make a mistake. Okay? Yes. Oh, no, no. Here I have 4 sig figs given in the problem. Over there, it was 4 and 3, so I have to go by the weakest length. Okay, everyone, this is your homework. Okay, you're basically telling me how long in distance. How many people heard of a light year? A light year is a measurement distance, is a distance measurement unit for what? Small or big distances? For astronomical and astrophysical. So if you know that light can go straight ahead 3 times 10 to the 5 or 300,000 kilometers in just how much? 1 second. How much distance would it be able to move if you gave it one whole 365-day year to go? Okay, that's your homework. All right. By the way, technically, you start with what distance? What unit? Go ahead. Kilometers. Are you changing your distance? No. You're changing your what? Your time. Exactly. So you need just to look at the what? At the time conversion. Okay. So this is your homework. So don't worry about it now, because I really want to actually start with the other handout, because that's usually the one that is slightly harder. Okay, first of all, my apologies for forgetting to print this for you. Okay, I will print it before the day is done. Okay, so whenever you pencils down, I'm just gonna basically explain what this is. Okay, so whenever you deal with either what, large numbers or small numbers, it is always good to actually instead of using powers of 10 like a scientific notation, to actually try to express them in what we call the large or the small scale. By the way, just so you know, listen up. In my course, I will always tell you what How many people remember that in grade 11, I always told you what unit to use at the end of the final answer? I also, which in a way, I'm always reminding you to what? Not forget your units at the end of the answer. Because oftentimes in math and physics courses, you lose communication marks just because you forgot the unit. I always remind you. Also, I always tell you what unit I want you to what to put the numbers in. In university, listen up. They do not, first of all, obviously, they do not remind you to put the units, but also they leave it up to you to decide which one of the best scales to use. They don't tell you, oh, express your answer in kilohertz or in megahertz. They just tell you, you've got a number, you express it in what in the most appropriate scale. So that's kind of what I'm going to train you to do today. So what are the large scales? So the large scales, the smallest large scale is what? Is the kilo. And kilo means what in Latin? It means what? Basically what? 1,000 or 10 to the 3. And by the way, it's the only what? It's the only lower case. All of the other ones are what? Capital letters. So after kilo, we get what? Mega, which is easy to remember. Mega is a million. Mega is a million. Giga is a what? What's after a million? And by the way, they only go up in threes. The only allowed powers are 3, 6, 9, 12, 15, 18, and so on. They only go up in threes. The next one is what? Tera, which is what's after billion? Trillion. So mega million, tera trillion. Easy to remember. The only one that's not the same, giga, is billion, like gigabytes. Okay? Those are the big scales. What about the small scale? You might, for example, talk about atomic radius, okay, or the size of an amoeba cell, or something like that. So, small scales. What is the biggest small scale? It's the what? Milli, which is literally this. Millimeters. What does milli mean? A part of a what? A part of 1,000 or 1,000th. Okay? Milli. What's after a milli? Micro. And now we have to start using what? Greek letters. Then what's after micro or smaller than micro? Nanotechnology. Okay? Nano. And they call it nanotechnology because the scale at which it happens is the nanometer or a billionth of a meter. So imagine you take this meter stick. You take this meter stick from here to here, literally, and you divide it into a billion parts. A billion parts. That's how big nanotechnology scale is. Okay? And then finally, you have what? You have what? Pico, which is not a billionth, but a trillion. By the way, can you still keep going lower? Of course. There is no limit to how low you can get or how big you can get because you're not inventing new physics. You're just inventing new what? New names and symbols. I am not going to give you anything lower than what? Pico. There's no point. I'm not testing anything new. Up to here, and you show me you understand. Okay? All right. So let's actually go to the handout. Okay. So when a change of scale is needed, I find that the best way to really understand it is to what? Is to play with exponents. Okay? Is to play with exponents. Using only what? Addition and potentially including what? Because the small scales could include what? Do include what? Do include negative numbers. Okay? So the most important exponent rule is this. This is the only exponent rule we're going to keep playing with. And it is right here. Everyone, just copy this. It's filled. There we go. How many people remember this from exponents? The exponent laws. When you multiply the same what? It has to be the same what though? It has to be, what do you call this part of an exponential expression? This is called the what? There's a reason they call it the b, because it's called the base, right? And it makes sense. The base of a building is always where? At the top or at the bottom? The base is always at the bottom. So if the bases are the same and you only what? And you only what? Multiply, what do you just do with the tops? Add them up. Even if they have a what? Even if they have a negative. So you're doing a plus c minus d. Okay? Here's the good news, everyone, about scale convergence. You're never going to have to do 3. You're only going to have to do what? You're only going to have to do 2. So it's only going to be b times like ac or a minus d. So it's only 2, not 3. Okay? All right. Let's actually what? Let's actually look at the question we have. All right. You don't have to understand the meaning of the question, okay? We're just dealing with the units here. So the resonant frequency of a certain chemical molecule, if you take grade 12 chemistry and you end up talking about, for example, like infrared radiation and quantum chemistry, then Mr. Mitrovic might talk about what? Something called resonance frequency. Has anyone heard of something called NMR? Nuclear magnetic resonance, or for, okay, MRI. How many people know MRI? How many people have had an MRI? If you don't, yeah, what's an MRI? It stands for magnetic resonance imaging. It's basically sending a frequency and detecting it back. Okay, so the resonance frequency of a certain chemical molecule is how much? 5.43 times 10 to the 10. What's this unit? Anyone remembers this? Grade 11 physics. This is hertz. Frequency is always measured in what? In hertz. We're going to deal with it a lot when we do waves on light. Okay, write it in what? Question. Pencils down, everyone. Why do you think I asked for gigahertz? Could I have asked for kilohertz? Could I? You know what? Let's actually let's just write the scale. Okay, so can someone remind me again? What's the kilo is how much? 10 to the what? Come on. 10 to the 3. Mega is how much? 10 to the, you just have to go in threes. Giga is how much? 10 to the, tera is how much? 10 to the, what's the, I'm not gonna say the problem, but what's the inconvenience about using kilo with that number? Josh, what's your power? What's the power here? Are they close or far apart? Okay, not the best choice. I'm not saying wrong, not the best. How about 6? But it's what? Is it better than kilo? It's better, but maybe not the best. How about 9? What's wrong with 12? It's what? It's bigger than the scale at which the number is given in scientific notation. Is it making sense now? That's how you think in university. The best scale is the what? Is the closest scale. That's not what? That's not what? That's not bigger than the number in scientific notation. That's all. Okay. So here's how we're going to think about this. From the large scale handout, the G stands for what? What does G stand for? No, as a word. Giga. Okay. Stands for giga. Giga. Which is associated with the exponent what? 9. Okay? Good. So what does that mean? That means that somehow we need to create a what? A 9 where? Here. Otherwise, I'm not going to be able to use it. So that means somehow we need to create a 9 in the exponent part, in this part of the number given above. Okay? Tell me how you can create a 10 using a 9. Only using addition. The only number that you need to add to 9 to make it all the way up to 10 is just what? 1. Okay. So obviously, the easiest way, go ahead. 10 equals 1 plus 9. Yes. I did? I think I did. No, there's already a 10. The 10 is already there. I'm trying to create a 9. Sorry. Oh, I see what you mean. How many people understand what Ali is saying? Okay. I guess I was create by bring in a 9 into the mix. That's what I mean. Do you see what I mean? But you know what? You are 100% correct. Technically, we are creating a what? A full what? A full 10. Okay? So either you take it my way or Ali's way. I am saying we need to bring in a 9. Ali is saying we need to bring in something to create a 10. Okay? But the important thing is, this is still the same thing, right? 10 equals what? 1 plus 9. Okay. So 10 is equal to what? 1 plus 9. All right. So that means what? How many people agree this is true? Just raise your hand if you think this left side is equal to that right hand side. Yeah. Basically, I'm doing exponents in reverse, right? In math courses, usually they give you the multiplication and they ask you to what? And they ask you to what? Add. Usually, Mr. Shivers, for example, will give you this and tell you what? Simplify using exponent laws, right? So you say, oh, it's the same base. Sweet. I just have to deal with these two. So I'm going to go here, and then you're going to go here. And then if the number is not too big, he might ask you to actually write the actual number instead of just leaving it in exponent notation. We are doing the reverse. We are splitting up the number and creating it as Ali said. Okay? All right. So what does that mean? Everyone, can I now, instead of writing times 10 to the 10 here, can I write those two things? Yeah. Again, what math says, if two things are equal, you can replace one or the other. Okay. So my next step, go ahead, is this. See, I am planting something in place of something else. So 5.43 times 10 to the 10 hertz is 5.3 times 10 to the 1 times 10 to the 9 hertz. Do I have a 9 explicitly shown now? Great. What's a 10 to the 9? What's a 10 to the 9? And the 10 to the 9 is the giga. So now what do? I am going to replace this times 10 to the 9 with just what prefix? With the G. What can I do to those two? Can I simplify this? Hey, what's 10 to the 1? What's any number to 1? Which is the same answer as any number times 1. It's not the same process. It just happens to be the same answer. It's the same number. So what's 10 to the 1? 10. So really, why keep those split when you can just what? Combine them together. So what's 5.43 times 10 to the 1? Just what? Just move the decimal point one shot here. How much do you get? 54.3. And we said this one is going to become what? Gigahertz. And now you understand what it means when people talk about what, like gigahertz and so on. There we go. I know that I am making this look very elaborate and a very long process. It's not. I'm going to show you now an example where you can do the whole thing in one single line. I'm just trying to break down the steps to make sure that you understand where each step came from. So always, the split part here is the giga. And this is much easier than saying 5.43 times 10 to the 10 hertz. Everyone, you know what's the most common mistake that people do right before they write their final answer? They do this. And I want you to tell me why you think that's a mistake. Why is this a mistake? Anyone? Say again? Okay, what do you mean? Okay, Ken is saying that's bigger. What do you mean? What did they do? They did double the work, right? Either you use what? Or you use 10 to, do you see what I mean? You cannot, the whole point of using giga is that I get not to show what? What did they do? You know what this number is now? 54.3 times 10 to the 18 hertz. It's a billion times worse. But basically people think, oh, I have to put both again. No, it's either or. That's the whole idea. Okay, so now you know that pitfall that many people commit. Okay, all right. Let's now what? Do a small scale. By the way, small scales are usually trickier to think of, not for any reason, but they have negatives in them. That's fine. By the way, hopefully you will get used to doing it exactly in a one-line kind of way. No need for all of this. Okay. All right, everyone. Let's go to the blank version. Okay. So here's the question. Go. All right. In cell biology, the diameter. What's the diameter, by the way? When you talk about a circularly rough shape, a diameter is for distance from where to where. What's the opposite of diameter? Radius. What's the difference between them? Radius is from center to the edge. How about diameter? Okay. Edge to edge. Thank you. Edge to edge, passing through the center. Because obviously you can make a circle and you can connect these two. Is that your diameter? No. Does anyone know what that's called? That's called a chord, like a guitar chord. It's basically a line. The biggest diameter, the biggest chord is your diameter, which means it has to pass through the what? The center of the what? Of the circle. Okay, good. So the diameter of a cell, like the whole size, is about 4.25 times 10 to the what? Does that make sense? Yeah, cells are very what? Good. Write it in what? In what? Why do you think I chose micrometer? Why do you think I didn't choose other scales? All right, let's do this. What's 10 to the negative 3? You remember the name? Think of a ruler. Milli. It's the closest thing to our scale. Okay? It's the closest thing to our senses. Milli. What's 10 to the negative 6? That's the one, micro. What's 10 to the negative 7? Sorry, not 7, I mean 9. What is it? Something technology, nanotechnology. And what's 10 to the negative 12? Picometer. What's my power? Why can't I use -3? Because that's a bigger scale, right? Think about, by the way, you can't say that's a smaller scale because 5 is bigger than 3. It's not 5. It's what? It's -5. And you know from math, -5 is smaller than -3. So that's a big scale. Which one is bigger, -5 or -6? No, which one's bigger? 6 is bigger than 5. -5 is bigger than -6. Think of temperature outside. Which one is warmer? -5 because it's closer to 0. What's wrong with -9? I mean, it is smaller than -5, right? But it's way too what? Way too small. How about -12? Even worse. So what's the most appropriate scale? Is it making sense now? Choose the closest number such that it's what? It's smaller than your domain. Okay? So according to the handout, mu stands for micro. I just give it to you here. Micro, go ahead. Micro, which is associated with the exponent what? 6 with a negative. Yes. Okay. So the only issue we have to worry about here is we have to deal with negative numbers or negative exponents. No problem. We're good for it. We want to create Ali, what do you want to create? You want to create a what? A -5. But here's the thing. We want to create -5. Okay, wait. We want to create if we say we want to create a -6 and we already have a -5, we simply write. Okay. Okay, everyone, forget this. What's my scale now? I want to write it in what? Can you tell me how to write -5 in terms of -6 or -6? -5 is equal to -6 plus. That's the whole idea. Write the original in terms of the new. Write the original in terms of the new. So let me see what I wrote. Oh, Ali was right. Okay. We do want to create a -5, and we already have a what? -6 in our powers. Why, by the way, everyone, why do you think I wrote it as +1 -6, not -6 +1? There's a reason. Uh, Not quite. Okay, everyone, I'll give you a hint. Why did I write 1 plus 9 in the first one? We did not write 9 plus 1. We wrote 1 plus 9. Anyone can take a guess? I'll tell you why. Look, which one needs to be left to the end? The 9. The thing you want in the scale. Is that what you want to say? Yeah. You always want the thing you want in your scale to be at the end. Which one is the one you want for the scale? The plus 1 or the minus 6? The minus 6. So always write it such that the scale number is always at the end. Okay? So let's actually write it down here. Okay, everyone, 4.25 times 10 to the what? Negative 5 meters equal. How are we going to split this? We said how much? How are we going to write just that? 1 plus 1 minus 6, or just 1 minus 6, whatever you want. So 4.25 times 10. Don't split yet, like the tens, just split the top. Plus 1 minus 6. Please keep writing your unit the whole time. Equals. I think I should make my handwriting slightly smaller. Just squeeze this. Okay. What can I now do with this 10? Can I split it up into two tens? Yes. So 4.25 times 10 to what first? 1 times 10 to what next? Negative 6. And you still have what? Meters. And now, what does this become? Just that. 42.5. And what does this become? Micro. Welcome to scale convergence. Done. That's it. Okay. Let's flip the page. I want to assign the rest of it as homework, but I just just want to do one more with you. And I'm gonna try to do one with a negative because usually they are the what? The trickiest. Okay? Let's see. Speed of light. No, that's a big scale. Ah, yes. By the way, get used to this one. Oh, we are gonna talk so much about the wavelength of light because that's basically half of the unit, waves and light. Okay. Can someone tell me what's my power there? Negative what? 7. What's wrong with this choice? Too big. Ooh, just a little bit bigger. Too small. Just right. Okay. Say again. What? It's bigger scale. If something is on the micro scale, it's bigger than anything with a minus 7. Okay. Okay. What's my first step? What do you write? You write the original number. So everyone, go ahead with me. 6.95 times 10 to the negative 7 meters. Can someone tell me how to write this such that you use a negative 9? What plus negative 9 gives you back negative 7, Junan? 2. You're right. 2 plus negative 9 gives me back what? How many people knew that? Okay. By the way, can you solve this as an actual equation? Yeah, you can. X plus negative 9 equals what? Negative 7. What do you do with this negative 9? You what? You move it. So it becomes x what? Well, plus negative 9 is really just a what? Just a negative 9, right? So it becomes what? X equals negative 7 plus 9. How much is that? You got it. It's the same idea. Okay, but it could be quicker if you guess. So, all right. So, 6.95 times 10 to the. What do I put up here now? Should I put minus 9 plus 2 or 2 plus minus 9? 2 plus minus 9, because the minus 9 is the thing for the scale. So 2 plus minus 9. I don't really care if you use a bracket or not, but let's just say we do. equals, can I split my tens now? There's nothing left to do but that. So 6.95 times 10 times 10. The first 10 takes the 2. The second 10 takes the minus 9. And what am I still missing? I still need to put the unit, meter, yes. And finally, hey, what's 10 to the 2? 10 times 10. 10 times 10 is 100. So really, it's going to become what? 695. And what does this part become with the multiplication sign? Nano. And that's how physicists talk about light. They never talk about in scientific notation. They always talk about what? By the way, our visible light, your eye right now, cannot see anything lower than 400 nanometers, which is red light, right? You can't see infrared. And you can't see anything more than what? What's the other end of the spectrum? Ultraviolet. That's why, how many people remember Roy G. Biv? Roy G. Biv, red, orange, yellow, green, BIV, blue, indigo, and violet. What's the, by the way, 695 roughly is the wavelength for violet. It's the maximum limit for your eye to be fired, like to be excited at and see. Okay? And that's unit and scale convergence.